Hello, students. I am Mansi Agarwal, Assistant Professor, ABES Engineering College, Ghaziabad. Today, we will be discussing our next topic of data structures, that is hashing. So, hashing is a technique that allows quick access while storing and retrieving data. Hash function is used to map data to a specific location. The components of hashing includes a key. A key can be a string or integer, which is fed and is returned by the hash function, and it is stored at a particular index or location in the array. Hash function is a function which receives this key as input, and we get the index where we have to store the particular key. Hash table is a data structure that stores the keys on a location or index after being computed using the hash function. The properties of hash function includes deterministic. Hash function must be deterministic. That means it should produce same output for same input. Then it should produce fixed size output. That means the size of the output of hash function must not be changed depending upon the size of input. It should be fixed, and for different size of inputs, it should produce fixed size of output. Efficiency. The hash function should be able to produce the output in less time complexity. Uniformity. The hash function should distribute the hash values into the hash table uniformly. This is done to avoid the clustering. Then pre-image resistance, that is, it should be computationally infeasible to reverse the hash function. Then the last property of hash function is avalanche effect. A small change in the input must produce a significant difference in the hash value to avoid retracking. Now, let us see the different types of hash functions. The first hash function is by division method. Let us suppose we have a few keys like 36, and we have 18. Then suppose we have 91, and we have 72 and 45. Suppose these are the keys, and we want to map them to a hash table. And suppose the size of the hash table is 7. Suppose this is the hash table. Now, as the size of the hash table is 7, we can write the indexes starting with 0 to 6. So this will be 0, 1, 2, 3, 4, 5, and 6. Now, in the division method, the value that we get after applying the hash function is given by k mod m, where m is the table size, hash table size, which is usually taken as a prime number. Like here, we have taken the size of the table as 7, which is a prime number, to avoid the collisions. We will discuss what are collisions in the later videos. And k is the key, that is the input we are getting. Now, suppose the first value is 36. We are going to modulo it by 7. So we will get 36 modulo 7. And this will produce a value 1. So 36 will be stored in the hash table at index 1. The next value is 18. We are again going to modulo it, divide it with 7, and we have to find out the remainder. As the remainder will come out to be 4, 18 will be stored in the hash table at index 4. Now coming on to 91, we are again going to modulo it by 7, and we are going to get 0. So this 91 will be stored at index 0. And similarly, 72 will be stored at index 2. And 45 will be stored at index 3. So this is how the division method works. We have to divide the input key by the number of elements that can be stored in the hash table. And we have to keep in mind that the hash table, the size of the hash table selected should be a prime number to avoid the collisions. And then we have to find out the remainder, and the key value will be stored at the remainder index in the hash table. The second type of hash function is multiplication method. So in multiplication method, the hash value that is represented by HK, this is computed by multiplying the key value with a constant, and then we will mod it. We are going to mod it by 1, and then we are going to multiply this value with the table size, and then we are going to take the floor. This is called the multiplication method. So suppose we have a constant A. Suppose we have constant A, which is having a value 0.45. We have to keep in mind that the value of A will always be in between 0 to 1. Right. So suppose we have taken the constant as 0.45 and we want to map 123. The value of key is 123 and we want to map this to the hash table. So in this case, first of all, we are going to multiply k with this constant a. So here after multiplying 123 with 0.45, we are going to get 55.35. So now we are going to mod it by 1. So basically we have to take the value which is there after the decimal point, right? So for this we are going to modulo it by 1. So after we take the remainder, we get 0.35. Afterwards, we have to multiply this with the table size. Now suppose the table size is 10. So we are going to multiply, if the value of m is 10, we are going to multiply this 0.5 with 10, and here we will get 3.5, and then we are going to floor this value. So we will get 3. So in this case, 123 will be mapped in a hash table of size 10, which will have the blocks till 0 to 9. This will be mapped at third index. So this is how we are going to compute the hash value for any key using multiplication method. Let us just take a look again. We are going to multiply the value of the key by a constant a, and this a is always taken from in between 0 to 1. And then we are going to take the modulus of this value after multiplication. We have to take the modulus by 1 so that we can get only the digits which are there after the point. And then we are going to multiply it with the table size. Here the table size is 10. So we have multiplied it with 10. If the table size would have been 100, then we would have multiplied it with 100 such that we will get here, we will get 2 digits and we can easily map it from 0 to 99. So here we have got the number 3. That means the key value 123 will be mapped to the index 3 in the table. Now, coming on to the next method, this is a mid-square method. So for this, let me just take a few keys. Suppose we have taken 36, and then we have taken 72, 43, 6, and suppose 18. So now what we are going to do is we are going to square these keys. Okay, we are going to square these keys and we are going to take the middle number as the index for the hash table. So by squaring 36, we have got 1296. By squaring 72, we have got 5784. And then by squaring 43, we have got 1849. And here we have got 36. And after squaring 18, we have got 324, right? So now, suppose we have a hash table again of size 10. Let me just create this hash table here. Now, in order to take the mid-square method as the hash function, we are going to take the middle digit of the square as the index. So as you can see that in first number, that is 1296, we have two middle digits. So we can take either of them. Usually we take the left one. So here the index becomes 2. 36 can be mapped at index 2. Again, for 72, there are two middle numbers. We can take the left one. So 72 can be mapped at index 7. Then for 43, again, we have two numbers. So 43 can be mapped at index 8. For 6, again, we have two numbers. So 6 can be mapped at index 3. So as you can see that after squaring 18, we have got 324, and taking the middle value of 324, we get the index 2. But we can see that this index 2 is already filled with 36. So we will not be able to store this 18 here. And this is where comes collision. This is called collision when we are trying to store a key into a block of hash table which is already being occupied. This is called collision. And there are various techniques to resolve these collisions, which are called collision resolution techniques. And we are going to look at these techniques in the next video, right? So this is how the middle square method works. We have to simply square the key values and we have to take the middle digit as the index in the hash table. Now, coming on to the next method, that is called the folding method. In this case, what we have to do is we have to divide the input key. We have to divide the input key into various parts. Suppose I can divide the key into part K1, K2, K3 to Kn, right? And then we have to add these parts. We have to add up these parts, K1, K2, K3 up to Kn. And then we have to modulo it. We have to modulo this value with the table size, with the table size. So suppose we have a key, we can take any number. Suppose we have 1, 2, 3, 4, and 5. Suppose this is the key 12,345. And now we want to find out the index at which this key must be stored in the hash table using folding method. So suppose I'm taking the number of digits for folding as 2. There can be different number of digits that you are taking here, because the table size is 100 and the indexes will be from 0 to 99. So I'm taking the the number of digits for folding as 2. So we will divide this number into 12, 34, and the last can be only 5. And we are going to add up these numbers, 12 plus 34 plus 5, and this will give us a number 51. Then we are going to modulus this number by 100. So we will again get 51. And if suppose I have a table of size 100, which is having indexes from 0 to 99, then this 51 can be found here, and the input key, that is 1, 2, 3, 4, and 5, can be stored at 51 index in the hash table. Folding method can also be done in few different ways apart from this. In the folding method, we can also reverse the input key. We can reverse the input key and then we can fold it. We can also fold from the boundaries, like we can take the numbers only from the boundaries. And there can be different ways of these folding methods. Then after these types of hash functions, there are various other types of hash functions as well. Like we have cryptographic hash function. These cryptographic hash functions are used to create the ciphertexts, and this includes SHA 1, and there are SHA 56, and then we have MD5, and so on. There are many cryptographic functions. The references taken for making this video includes Tenenbaum and Langsam, data structures using C, Horowitz and Sahani, fundamentals of data structures, then data structures Shom series, and data structures using C, Thareja. Thank you.